All right, guys, for this problem it says, suppose that the height of water draining out of a conical tank is changing at a rate of negative 0.2 feet per minute, and the radius is changing at a rate of negative 0.1 feet per minute. What is the rate of change in the volume when the radius is r is equal to 1 foot and the height is h is equal to 2 feet? Notice that they already give you the volume of a cone. It's 1/3 pi r squared h. Now I'm going to go ahead and underline some stuff. Notice that the height of the water draining out of a conical tank is changing at a rate of negative 0.2 feet per minute, and the radius is changing at a rate of negative 0.1 feet per minute. What is the rate of change in volume? So what is rate of change in volume when the radius is 1 foot and the height is 2 feet? All right, so obviously for this problem, it's asking you to find the rate of change in the volume. So it's wanting you to find the derivative of volume with respect to time, or how fast the volume is changing over time. So since I've already got the formula, I'm going to take the implicit differentiation of this with respect to time. So in other words, the derivative with respect to time of v equals the derivative with respect to time of 1/3 pi r squared h. Now, notice with the rules of implicit differentiation, the variables do not match, right? This is t for time, this is v. So when I take the derivative of v, it's a power of 1, so it's just going to be 1, but I'm going to have to write dv over dt, the derivative of the volume with respect to time. Also notice that this is 1/3 pi. That's a constant, so we can pull that out, and so that I have 1/3 pi, the derivative with respect to t of r squared h, r squared times h. So notice, guys, that that is a product, so we're going to have to use the product rule. First times derivative of the second plus second times derivative of the first. Notice that it's with respect to t, so the variables do not match. So whenever I take the derivative, I'm going to have some extra stuff here. So let's go ahead and write this out. This is going to be dv over dt equals 1/3 pi bracket, because I'm going to have to take the derivative of this first, so r squared times derivative of the second. Well, the derivative of h would be 1, but since it's the derivative of h with respect to t, I'm going to have dh over dt plus second, so h, times derivative of the first. The derivative of r squared would be 2r, but since the variables don't match, I'm going to have dr over dt. All right, I could clean this up a little bit and have dv over dt is equal to 1/3 pi, and then have r squared dh dt plus 2hr dr dt. Since I'm trying to find the derivative of the volume with respect to time, or the change in volume, all I'm going to do now is simply plug in or substitute all of the values. So the derivative of the volume with respect to time is going to be 1/3 pi bracket r squared, so r is 1, so 1 squared times dh dt, or the change of the height, which is negative 0.2, plus 2 times h, which is 2, times r, which is 1, times dr over dt, or the rate of change of the radius, which is negative 0.1. And so what we're going to have to do is we're going to have to calculate that to find my final answer. So I'm looking for 1/3 times pi, and then it's in a bracket, so I'm going to have 1 squared, so times 1 squared times negative 0.2, close parentheses, plus 2 times 2 times 1 times negative 0.1, and that would give me an answer of negative 0.628. I'm just going to round out to 3. So negative 0.63. Since this is volume, I could say that that is feet cubed per minute. And so then that would be my final answer. It's the rate of change of the volume is decreasing. That's why it's negative. It's decreasing at 0.63 cubic feet per minute.